Assalamu alaikum. Hello everyone. Today's video is a first video on functions. Um, let's define a function. So a function is a special relationship where one input has exactly one output. Different outputs, sorry, one output might have different inputs, but one input will have exactly one output. We'll see a couple of examples how. Now, what you can see is something called a function machine, and we're gonna use this as an example to show what a function is like. So here I'm going to use the number 3 as my input. I'm gonna say multiply by 5 and subtract 2. So my input is 3 times 5 is 15, minus 2 is 13, and that's my output. So if my function, the input, if I call it x for this particular function, I can write down an equation. So I'll do x times 5 subtract 2 to give me 5x minus 2. Now a lot of the times functions are written like this: f of x, so that basically stands for function of x, and in this case it would have been 5x minus 2. So if someone asked me to find the function of 4, basically what that means is when the x value is 4, what is the value of this function? So I would basically input 4 into that function machine. So it would be 5 times 4 minus 2, which is 20 minus 2, which is 18. Right, almost made a mistake there. Almost. Okay, let's go on to the definition which I mentioned earlier. So I said that you could have an output having more than one input, but an input will always have one output. What that means is, let's look at another function. So let's just say f of x, the function of x, is equal to x squared. Now the function of x can be written as f of x. Sometimes it is also written as g of x as well, and some other letters are used as well. There's no reason, but f of x is the most common way of writing it. So if I worked out f of let's say 5, the answer would be 5 squared, which is 25. But if I was to work out f of minus 5, the answer would be minus 5 in brackets whole squared, which is also 25. So here I can see there's two outputs of 25, right? So that's the same output, but I'm getting that same output from two different inputs, right? So but when I put in 5 into the equation, like as an input, there's only one output of 25. So function, the input will have only one output, but one output can have more than one input. Anyway, that's the basics of functions. We are going to look at composite functions and inverse functions as well, right? So let's just do it on this video. Hopefully it won't be too long. So composite functions. Now composite functions are functions of a function. Sounds a bit confusing. Sometimes it can be, actually. Let's see how these work. Right, so first I'm gonna have function of x is equal to 2x plus 3. So say another function of x is equal to 6x plus 1. So just as a background, if someone asks me what's f of 4, well, to find f of 4, wherever x is, I'm gonna get rid of it and replace it with 4, or substitute 4 into the value of x. So I'm gonna have 2 times 4 plus 3, 8 plus 3, which is 11. And if someone asks me to find g of 4, six times 4 plus 1, 6 times 4 is 24 plus 1, which is 25. Right, now we're gonna mess things around a bit. So if I asked you what's f of g of x, that's confusing now, right? So I'm gonna put a pair of brackets here. So we know that originally the function of x is 2x plus 3. Now remember, when we found f of 4, wherever x was, we got rid of it and we replaced it with 4. Yep. Now we're finding the function of g of x. So what we're gonna do is we're gonna go back to our original function of 2x plus 3, and where x is, we're gonna get rid of it and we're gonna replace x with g of x. So what this will look like is 2 open bracket 6x plus 1 close bracket plus 3, and you expand it. 2 times 6x is 12x, 2 times 1 is 2 plus 3. (12x plus 5), that's f of g of x. Now similarly, if I was to find g of f of x, again I'm gonna put an imaginary set of brackets here. So we knew that g of x was 6x plus 1. So when you found g of 4, wherever x was, we got rid of x, we replaced it with 4, right? So this time we're gonna go back to the original g of x, 6x plus 1, and wherever x is, we're gonna get rid of it and replace it with f of x. So let's see how this works. So we're gonna have 6 open bracket 2x plus 3 close the bracket plus 1. Now when I expand this, that's going to become 12x plus 18 plus 1, which is going to be 12x plus 19. And that's an example of how composite functions work. So you're working out the function of a function. And someone asked me, okay, what's f of g of, let's just say, let's use 2. So we'll do 12 times 2 plus 5, which is 24 plus 5, which is 29. If I was to do the same thing for g of f of 2, 12 times 2 plus 19, 24 plus 19, which is 43. Okay, and that's how composite functions work, really. And we're gonna do another video on inverse functions after this, right? So thank you for watching. This video has been a bit long. Hopefully it helps. Thank you for watching.